Okay, welcome to virtual GED class. We've got GED student Marily here with us today, and she's in chat mode. She doesn't have sound going on, so if she has any questions, I'll read them aloud to you guys. But we are going to be talking about graphing lines using the slope-intercept form. Super excited to finally get to this class because it's like giving you guys a gift. This is a really easy thing as long as you remember it, and it comes in very handy on lots and lots of GED problems. So first, I'll just ask you to remember from last class that we took a look at the formula sheet, and on the formula sheet, we found something called the slope-intercept equation of a line. And when I talk about the formula sheet, of course, I'm talking about the GED formula sheet. And what we saw when we looked at that on the formula sheet was we saw the equation y equals mx plus b. Y equals mx plus b. So even though you might have to have that one memorized for your college classes, you don't have to have it memorized for the GED since it is on the formula sheet. So this is the equation of a line. And what do I mean by that? I mean, whenever you have an equation that looks like y equals, and then m, even though I have it written as m right here in this generic equation of a line, m is going to be written as some number. So this m will be filled in as a number. It might be 5 or -3 or 17/4, but it will be a number. And then you'll still have an x. And then this plus could actually be a plus or minus, depending on if your b is a positive or a negative, but we are going to have a b. And we learned that this m and this b stand for something. And if you can just remember what they stand for, it's super duper easy. It's going to make your life so easy. So remember, I joked that mathematicians aren't that creative. We called this the slope-intercept form of a line because by looking at it, you can see both the slope and the intercept. So if your equation of a line looks like this, that m right there is actually the slope of your line. Whatever number is multiplying with x is x's rate of change, how fast x is, or how fast our function is changing value, and so that's your slope. And then your b, of course, is your y-intercept. Ms. Marily, is all this familiar to you? Do you remember all this? Marily says she's good to go. So let's build on this knowledge that we've already learned. Turns out you can actually use this. So again, we'll say if the equation of the line is in slope-intercept form, and remember we had a quick check last time, and that was if y was alone. It was a pretty good bet. In fact, I made that joke, why am I always alone? Even my ex is married with a baby. That's how I remember this. Why am I always alone? We see y alone on its side of the equal sign. Even my ex is married. There's Mrs. X with a baby. That's how I remember that guy. But if the equation is in slope-intercept form, okay, we can see the slope and the y-intercept, and we can use those to graph. So you can use the m and the b to graph your line. So we learned how to graph lines another way in another video. We talked about graphing it using a table, and that was an intuitive way, but it took a really long time. You had to pick 3 points. You had to simplify the equation with each of those 3 points in there to solve for y, and then you had to graph those points on a line and connect those points. It was kind of a lot of work. And so this is the easy way. If the equation is in slope-intercept form, there's another way to graph a line. And we can use the m and the b to graph lines. And so what we'll do is we'll start with m. Remember what, I'm sorry, I just lied to you. I'll delete that in the final video, but you're going to start with b. Remember, b is the y-intercept. It's the place where our graph crosses the y-axis. So for example, if I had a graph here, and on it was graph, we had the graph of a line. My y-intercept would be this point. That's my B. The place where my graph crosses the y-axis. And then remember the slope, the m. I joke that the m is a movement because it tells you how much to rise and how much to run. Okay, let's go apply this knowledge. Enough notes. Let's go give it a try. Let's take a look here at example 1. Now, here's one of the nice things. Yes, today we're going to look at making the graph ourselves. How would I actually graph the line if I was just given the equation? However, because the GED often has multiple choice problems, you might not even have to graph the line. You might just have to recognize the graph of the line. And that's super duper simple. As long as you remember the y equals mx plus b information. So can you see here that y is alone? So I have y alone, and then I have some number of x, and then I'm adding or subtracting a number. So this thing is clearly in slope-intercept form. And as a mathematician, I always cheer when we are in slope-intercept form, because that means we are going to be able to see that rate of change, that slope, and we're going to be able to see that y-intercept, that b. So looking at this equation, y is equal to 3x plus 1, do you remember which one is the slope and which one is the y-intercept? So remember, to find the slope is the rate of change. It's how quickly my graph is changing. And so the slope is always going to be a multiplier. So do you see that number here? 3 is multiplying with x. That is my slope, my m. Or another way to remember it is just to write that equation underneath. Y is equal to mx plus b. This is the equation right from the formula sheet. And so it's easy enough to see that 3 is the m because it's shoved up against x. 3 is the slope. Is that cool? Now I look and I see that with 3x, I am adding 1. Whatever number is adding or subtracting with the x is going to be the b, the starting point or the y-intercept. And so this is going to be my b, positive 1. Okay, so I have a slope of 3 and a b of 1. Is that cool? Wonderful. So we said that our first step when we go to graph a line will be to look at our b first. Since b, the y-intercept, is an actual point, it gives us a starting place. So we are going to start with b. So what do I know if I know that my b is 1? I looked at my equation and I saw that my b is 1. Well, that means that my line crosses the y-axis at 1. That's what it means to be a y-intercept. It means that's where I cross the y-axis. So let's take a look at these 4 graphs we've been given. This first graph, I can see my line crossing the y-axis at this point right here. And we might be wondering, well, what is that point? It's a little hard to see. I wish I should have pulled up my graph a little bit larger at first. I wonder if I still can. Let's see if I can. You're going to have to ignore my ugly writing, how it doesn't line up. But take a look here. You can see that this crossing point is halfway between 0 and 2. So my crossing point is halfway between 0 and 2, meaning that I'm definitely at 1. So this particular graph here does have a y-intercept of 1. Okay, so taking a look at my next graph, I want to see where its y-intercept is. So let's take a look. I can see that my graph here crosses the y-axis at someplace under 0. In fact, I would say that one actually looks like it has a b of -1. This cannot be a correct answer. I ruled it out right away just because it has the wrong b. So let's take a look at this graph. Where is this graph crossing the y-axis? Could that possibly be a 1? Absolutely. That's definitely, looks like we're halfway between 0 and 2 again. I would say that's a b of 1. That's a possibility. So we might be looking at this graph. Now, looking at my next graph, does it have a y-intercept of 1? Absolutely not. You're right, Miss Merrily. So here was my 0, here's my 2. I'm up past 2. It looks like I'm probably at a b of 3. This is not an acceptable answer. Okay, so I started with my b and used that to narrow it down. My b is my y-intercept. So 2 of my graphs here have a y-intercept of 1. So now let's look at those a little closer. Looking at these 2 graphs, the first one and the third one that I said had the right b, now I want to look at their slope. So now an interesting thing happened with my slope here. I looked up here in my equation and I saw that my slope was 3, my m was 3. But remember, for step 2, as we're doing slope, slope is supposed to give us both a rise and a run. I even joked that M stood for movement. It's supposed to give us both a rise and a run. We said slope was the rise over the run. Now, my number 3 does not look like a fraction. It's going to be super important to you to realize that you should make your slope look like a fraction. So to make any number, whole number, this is a whole number right here, 3, to make any whole number look like a fraction, you can just throw it over the number 1, because 3 one whole things is the same as 3. And so it is important to do that so that you can see both your rise and your run. We don't have a run of 0, we have a run of 1. Okay? Okay, so I'm going to start right at that B I was looking at, and I'm going to try rising 3 and running 1. So I'm at 1 right now. Here, I rise 1 up to 2, rise 2, and I rise 3. So I just rose 3. I went up by 3. Is that cool? Now I'm going to run 1, a run of 1. I just went over 1. Did I end up on my line? No way. My line got a much smaller slope than that. I did not end up on my line. My line doesn't look like that, okay? And so this guy does not have the right slope. Let's check the other one. So again, starting at that y-intercept, I could rise 1, 2, 3, and run 1. A rise of 3 and a run of 1. Can you see how this time I actually ended up on the line, Miss Merrily? Wonderful. So we can see that this line really does have a slope of 3 over 1. And that makes sense to me because a slope of 3 is pretty steep. And we can see that this is a pretty steeply rising line. Definitely has a slope of 3. And so this graph had both a y-intercept of 1 and a slope of 3 over 1. So it is the one that matches my equation. C is the correct answer for this one, or the third graph. Which graph represents the equation y equals 3x plus 1? It's that one. Are you good with that? Wonderful. So let us move on and look at some other examples. So I'm going to clear this sucker and look at number 2. Okay, and I'm going to start moving a little faster. Okay, so this thing is definitely in slope-intercept form. I can tell because it's in the y equals some number of x plus a b formula. And so just looking at it, I can see that my m is what? What is my slope, Miss Merrily? What's my number shoved up against x? -1/2. -1 over 2, that whole number that's shoved up against x. We can see there's the slope right there. Great. And then take a look, what is my b? And remember to include the sign. So it is not just 3, since it's minusing 3, it is -3. the sign gets included. If it was adding 3, it'd be positive 3, exactly. So wonderful. So remember that I said start with the B when we look at our graph. So I'm going to start by looking for graphs that have a B, a y-intercept of negative 3. So looking at this graph, I'm crossing somewhere below 0, but I'm not yet to negative 3. This is 0, negative 2. Negative 3 would be down here somewhere. So this graph is not going to work for me. Again, same thing with this one. I'm crossing somewhere below 0, but not far enough. This one is not going to work out for me. But both of these graphs have a B of negative 3. I can see my line crossing the y-axis at negative 3. My line crossing the y-axis at negative 3. Cool. So I took care of the y-intercept first. Now it's time to do the slope. So remember that slope is a movement, and in this case, my slope is going down 1 for every 2 it goes over. Again, it's going down 1 for every 2 it goes over. I don't even have to do any work for this because I can see that only one of these lines is sloping down. Remember that we read a graph from left to right, and we can see that this line here, if I trace it from left to right, is going down, whereas this line here is going up. I don't need to count to know that this guy has a positive slope and this guy has a negative slope. I bet you anything C is my correct answer again, because my slope was negative 1/2. Does that make sense, Marilee? Wonderful. Now let's just confirm that we're right though, because we've been practicing counting that rise over run. So it's negative 1/2, and I like to pair that negative with my top number, meaning I'm going down 1. So starting at my y-intercept, I go down 1. And then I run or go over 2. And remember to run right if you have a positive number. It's going to make your life a lot easier. Right is the positive direction. So that's a negative 1/2 slope. So my y-intercept checked, my slope checked. This was indeed the correct answer. Correct answer there is C. Okay, let's move on to some trickier ones. Okay, so which graph represents the equation y equals negative 2x minus 1? And I can see once again that this is y equals mx plus b format. So that means that my slope is what, Miss Marilee? My slope, my m, is equal to what number? So looking at this equation of a line here, can you see the number that's shoved up against x? Negative 2. Great. So the slope is negative 2. Don't forget signage. Great. And then my b, my number that's adding or subtracting with y, is what? Absolutely, negative 1. Thank you for remembering your sign. So we said when we would check this out on a graph, we would start with our b. We'll start with our y-intercept. So let's look for a graph that has a y-intercept of negative 1. Oh, this one's going to be kind of simple. I see a couple graphs with a y-intercept of probably negative 1. Which ones look like they have a y-intercept of negative 1 to you? The third one. I agree with you. The third one definitely has a y-intercept of negative 1. I can see between 0 and negative 2. I'm crossing right there. I see one more that appears to have a y-intercept of negative 1. Do you? Yes, wonderful. Okay, so I think that would definitely be the first one here. Y-intercept of negative 1, b equals negative 1. Okay. Now the other two I'm going to rule out because this one has a y-intercept of negative 2. Nope. And this one has a y-intercept. I'm way high. I think I meant like positive. I don't even know what I'm at. It looks like the numbers got inverted on that one. Anyway, that's definitely positive. Crossing that off. Okay, so looking at this sucker, I've got 2b equals negative 1. Now I want the one that I think has a negative 2 slope, a slope of negative 2, because after the b of negative 1, we'll deal with the slope, the m of negative 2. Now I can tell that only one of these graphs has a negative slope because only one of these graphs is going down. Which one of these graphs appears as if it's going down? The first one or the third one, Miss Murley? Remember, if you're having trouble telling, you can trace your, Yes, exactly. The first one is going down. If I trace this graph from left to right, I can see that line going down pretty sharply. Okay, now so that's my guess right here, but I'll just confirm that it really does have a slope of -2. So remember, when you're dealing with slope, you want a rise and a run. So we're going to take that -2, and we're going to throw it over the only number you're allowed if it's a whole number, and that's 1. -2, one whole things is the same as -2. And so this is my rise, or really fall since it's negative, and this is my run. So starting at my B, I'll go down 1, 2, and I will run 1, and I can see that, yes, indeed, I do end up on the line. I had a good guess. The first graph is the correct answer. Is that good? Wonderful. Okay, I'm going to clear this. One last example like this, the simple kind. And then we will look at how it gets a little more complex when we have to do it ourselves. Wonderful. Let's take a look. So number 4 says, which graph represents the equation y equals 2/3 x plus 2? And once again, I have super duper good news. This is in slope-intercept form. I can see that my y is alone. I can see that I have some number of x's. And I can see that I have that b. So y equals mx plus b, I'm in that right form. And so I should be able to see both my m, which is my slope, and my b, which is my y-intercept. So recalling that the m is always shoved up against the x, looks like my slope here is 2/3, meaning 2 is my rise, and 3 is my run. And b is my y-intercept, and I can see my b here is +2. So that means that my line crosses the y-axis at +2. Okay. So looking at these graphs, once again, I see 2 graphs where my line crosses the y-axis at +2, 2 graphs with a y-intercept of +2. Can you see them, Miss Marilli? Definitely. The first one definitely is crossing that graph at 2, so the first one's one of my options. There is one more that's a decent option. Can you see the other one that looks like it's probably crossing at +2? Again, with the third one, I see that here's 0 and here's 2, and I'm crossing somewhere between. I don't know, maybe I'm crossing at 2/3, but yeah, the fourth one, exactly right. So this one is not a good option. It doesn't have a B of 2, but this one does. I'm crossing right at 2, and I know my graphs are really small and hard to see the numbers. I'm sorry. But definitely those 2 are both an option based on that y-intercept of 2. Now we'll deal with the slope of 2/3. So if my slope, or my m, is 2/3, what I'm saying is that for every 2 I rise, I will run 3. So I can start right at that y-intercept, and I can try rising 2, 1, 2. And running 3. 1, 2, 3. I am not on my line. I am off of my line. This line has too steep of a slope. Let's check out the other one. So rise 2, 1, 2, and run 3. 1, 2, 3. There, I rose 2 and I run 3. This graph has a slope of 2/3. Yeah, it really says I like it. And it has a y-intercept of 2, and so this must be my graph. The fourth graph is the correct answer. Cool. So let's step up our game a little bit. We're going to make it a little bit harder and have the problems where we don't have multiple choice answers, but we just have to graph ourselves. Could this happen on the GED? Yes, it could. They have what they call hotspot things, so they could use a hotspot question to try to make you graph an equation. So let's look at this first one. Example 5 here says graph the equation y equals -2/3 x plus 1. So once again, I see that I'm in that slope-intercept form that makes me so happy, the lazy girl form of a line. I can see my m. My m is -2/3. And I can see my b. My b is 1. So we are going to start with our B, our y-intercept, because that's actually a point. It is the point where my line crosses the y-axis. So I'm going to come here on the y-axis. This is my y-axis, the one running up and down. And I am going to find 1. So here's 2, and here's 0. I'm guessing 1 is halfway between there. So that is where my line is going to cross the y-axis at that point. Now from there, we are going to make a movement. Remember that slope is a movement. It tells you how to move from one point on the line to another point on the line because it is the rate of change. Now our slope was negative 2/3. I like to put that negative up top so that I know that that's how much I'm going to rise. So it's a negative 2, so I'm actually going to go down 2. And then I am going to run 3, and notice this is a positive 3, so positive is the off to the right, so I'm going to go right 3. So starting from this point, I'm going to go down 2, 1, 2. Remember, I started from the B, not from 0. And then I'm going to go right 3, 1, 2, 3, down 2 over 3, and I draw a second point because the slope takes me from point to point on the graph. Now, it doesn't matter how many times you apply that slope. You could do it over and over again. You could go down 2 and over 3 again. No matter how many times you did it, you would be on the same line. Again, if I went down 2 and over 3, I'd be off my graph. I don't have enough space. But you can see that these points all kind of connect. They're all on the same line. So whether you do apply the slope once or you apply the slope multiple times, you're going to get that same line here. So I connect the points with a line and I throw arrowheads on my line. I have now graphed the equation. Wonderful. Let's try another one. Number 6 says graph the equation y equals 3x minus 2. So once again, this is in slope-intercept form. Y equals mx plus b form, meaning I can see the slope. My slope is 3. Remember, you want your slope to look like a fraction, so it's going to be 3 over 1, 3 one-whole things. And my b is negative 2. Now we said we'd start with our b, so coming right up to the y-axis, I get to negative 2 and I drop a point. That's a b of negative 2. And from there, I'm going to rise 3 and run 1. So I'll rise 1, 2, 3, and run 1. And I drop another point, the second point, after I make those 2 movements. And connecting those points forms my line. And there you go. There is the line with a y-intercept of negative 2 and a slope of 3 over 1. Or a slope of 3. Really, really simple. I mean, it's really simple, but you have to remember this y equals mx plus b and how to read it. Wonderful. So let's look at 2 trick problems that often throw students, okay? This is based on what we did the other day. So if you haven't yet watched it, I would watch the slope from slope-intercept form video because all this applies. But we're going to look at number 7 here. It says graph the equation y equals negative 2x. And students sometimes get confused. They tell me this is not in slope-intercept form, but it is in slope-intercept form. My y is alone. I have some number of x's. And I do have a number adding or subtracting with x. You might say, Kate, there's no number. I don't see a number adding or subtracting with x. That means there's nothing there. I say that again. That means there's nothing there. There's nothing adding with x. Well, we have a number to represent nothing, and that's the number 0. So this, when I have this here, I do have some number of x's because I can see that negative 2 shoved up against x. So that means that my m, my slope, is negative 2. And my b, my y-intercept, is actually at 0. When it appears there's no number adding or subtracting, my y-intercept, or my b, is at 0. Does that make sense, Miss Murley? Okay, wonderful. So what does that mean to us? It means that our line is actually going to cross right here at the origin. That is where I am at 0 on my y-axis. That is where I'm at 0 on my y-axis. So that is a y-intercept of 0. Now, since that is my y-intercept, I will start there to do my slope. Now remember, if you have a slope that's just a plain old number, you got to throw it over 1 so you can see both the rise and the run. So I can see that I'm actually going down 2 and over 1. So from this y-intercept, I will go down 2, 1, 2, and over 1, 1. Now that does make my line, but I want it to be nice and straight. My last line was too crooked. It irritated me, so I'm just going to keep going. Down 2 and over 1. Down 2 and over 1. This ensures that I have a nice straight line and I don't have to rely on my own artistic abilities. I could even go up to if I gave the negative to the bottom number. So again, it doesn't matter where you put the negative, you're going to get the same kind of a slope. So I could go up to, now this is a negative 1. So that means I'd be going left 1. Left is the negative direction. And we can see that that's the same basic slope. It doesn't really matter which direction you're going, up 2 and over 1. So connecting these, I can connect all these dots. It's easy to see that they're all in a line. That's the definition of a line, is something with constant slope. So you could apply the same slope over and over again. You're going to get the same line. Okay, wonderful. Let's look at my trickiest example, number 8. Okay, here I'd like to graph the equation y equals 1. And this is another one of those equations where people will tell me, Kate, it's not in slope-intercept form. But I would argue, yes, it is. It is in the form y equals some number of x's plus or minus a number b. Now, the trick is, clearly we can see we just have one number over here. Is this number an M or is this number a B? The way to tell is to look for an X. So you can see that I don't have an X here. M is always, 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 always shoved up against X. So that number cannot be an M. That one is definitely a B. So you might be saying, well, my goodness, then what is the M? What is the slope? Well, how many X's are there? There are no X's. I see no X's in this equation. That means I have a slope of the number that means nothing. I have no X's. So it's like I have 0 X's, so my slope is 0. No X's is 0 X's, so my slope is 0. And I can write it out the long way. Y equals 1 could also be written as y equals 0 x's plus 1. But mathematicians are so lazy, we never brag about things with zeros. I'm just expecting you to know that if I don't write any x's, there are no x's. And so my m, my slope, is 0. Okay, knowing that, let's graph this line. So my b is equal to 1. So I'm going to cross the y-axis at 1. So here's 0 and here's 2. Y must be halfway between them, or 1 must be halfway between them. So that is my b of 1. Now, I say my line has a 0 slope. It has a 0 slope. What am I saying? I'm saying it doesn't go up and it doesn't go down. It's not sloped at all. It's flat. It's a nice horizontal flat line. When your line has a slope of 0, and this we did discuss at quite some length a few videos ago when we did the intro to slope, but a slope of 0 is a flat horizontal line, which I sure feel like makes sense, because hello. If I said the road was not sloped, you would know it was a nice flat road. I don't got to walk up. I don't got to walk down. It's a nice flat road, a slope of 0. And so I get this flat horizontal line. Okay, this is as tricky as it gets to graph in slope-intercept form. So I'm pretty much done with this concept. Yeah, it's actually easier than all the other ways to graph lines. But like I said, but the easier something is, the less likely you are to remember it, because it was so easy, like it doesn't penetrate into your memory because you didn't have to work very hard to do it. So it'd be super important to practice this quite a few times to help cement your memory. Okay, Ms. Marley, thank you for coming. I just love not having to talk to myself in class. So, and I got to tell you, it's the people who show up, and those are the people who pass. So can't wait to see you pass your test, okay? And hopefully I'll see you Thursday.